A study provided data on variables that may be related to the number of weeks a manufacturing worker has been jobless. The dependent variable in the study, weeks, was defined as the number of weeks a worker has been jobless due to a layoff. The following independent variables were used in the study. So I've got a response variable, weeks, and then independent or predictor variables, age, education, which is the number of years of education, married, which is a dummy variable that's 1 if married, 0 otherwise, head, which is also a dummy variable that's 1 if the head of household and 0 otherwise, tenure, which is the number of years on the previous job, manager, which is the dummy variable 1 if a management occupation, 0 otherwise, and sales, which is a dummy variable 1 if a sales occupation, 0 otherwise. Here's a matrix plot for the quantitative variables, just so we can get a quick look at the data. Develop the best one variable estimated regression equation. So it turns out that the best one variable model has age as the independent variable. Next, use the stepwise procedure to develop the best estimated regression equation. Use values of 0.05 for alpha to enter and alpha to remove. And so if we use Minitab to perform that stepwise procedure, we obtain the following model. So it has age, head, manager, and sales as 4 independent variables. Use the forward selection procedure to develop the best estimated regression equation. Use a value of 0.05 for alpha to enter. And it turns out that the best forward selection model is the same as the best stepwise model that we just obtained. So again, the same 4 independent variables, age, head, manager, and sales. Use the backward elimination procedure to develop the best estimated regression equation. Use a value of 0.05 for alpha to remove. And it also turns out that for this particular application, this isn't always the case, but for this particular data set, the best backward elimination model is the same one as the best stepwise and best forward selection models, with age, head, manager, and sales as the independent variables. Finally, use the best subsets regression procedure to develop the best estimated regression equation. So if we run the best subsets routine in Minitab, we obtain various models for 2, 3, 4, 5, and so on independent variables, and we also obtain various criteria that we can use to compare the different models. And if we look at that list and discover that the one with an adjusted R-squared of 53.3 and standard error of the estimate S 16.179, that model has age, married, head, manager, and sales as the independent variables. So this is a different model to the one we found with the stepwise forward selection and backward elimination methods.